Hey guys, welcome back to another video. It's been a long time, right? We're going to be discussing about applications of trigonometry, better known as heights and distances. This is a very important chapter. The most important thing in this chapter is trigonometric ratios. These trigonometric ratios are going to help us find missing measurements of a triangle. Example, if we have a right angle triangle over here, ABC, and its height is given and ask us to find other two sides which we don't know. They can be x and y. Angle C is theta. With the help of this measurement and this angle, we can find the other two sides. That's great, right? So without any further ado, let's get started with the explanation. So angle of elevation. We have our friend, this guy right here. I don't know what to name him. If you have any ideas, drop him in the comments. We're gonna be seeing him a lot now. This guy, he's looking up. He is looking towards something. Maybe this can be a tower. This triangle, this AB is a tower of some height. He is looking to the top of the tower. Maybe there's something over here. There's a bird sitting over here. He is looking up, and the horizontal line will be the line that is perpendicular to the horizontal line will be BC. Okay, the horizontal line is BC and he is looking up. So when he looks up, he's looking at something. We can draw an imaginary line. So that's going to be AC. That's the line of sight. It's called the line of sight. It joins his eye to the bird. So line of sight shows where he is looking, what he is looking at. Horizontal line is the line below him that connects the tower, that is B, to C. The tower to him, the distance between the tower and him, that's going to be the horizontal line in case of angle of elevation. So in angle of elevation, it is the angle that is formed between the horizontal line and the line of sight. Okay, so if the line of sight is upward from the horizontal line, angle of elevation is when you are looking up. Okay, it'll only be counted when you are standing over here. You could be even this. You're standing over here. You're looking up, something taller than you, higher than you. That is only when you consider angle of elevation. If you are on top and looking down at something, it's gonna be angle of depression. Okay, if you look up, it's angle of elevation. Look down, it's angle of depression. So angle of elevation is the angle that is formed between the horizontal line and line of sight. So you know what a horizontal line and line of sight is, right? So let's move on to angle of depression. It is also essentially the same thing, but now you are looking down. So your eye meets the ground. The point where this guy right here looks down and meets the ground. His eye meets the ground. That is the line of sight. So the line from which he sees the ground, it's the line of sight. And the horizontal line now changes. It's gonna be over here. I'm pretty sure you all can see. The horizontal line comes here from A to X. This becomes imaginary now. Before, the line of sight was imaginary. Here the horizontal line and the line of sight both are imaginary. Only the height of the tower is real and distance between the tower is here. These two are imaginary lines drawn by us for measurements. So the angle of depression is angle between horizontal line with the line of sight. Horizontal line with the line of sight, but you are looking down. This time it is downwards, right down. So angle AXAC, angle XAC is equal to theta this time. Angle XAC is equal to theta. But how will you use it in a triangle? Right? BAX are a 90 is 90 degrees, BAX. And also ABC is 90 degrees. Because it is a 90-degree triangle and horizontal line will be perpendicular to the height of the tower. Since these two are 90, the lines will be parallel, right? And this is a transversal. we can use alternate interior angles and say that angle XAC is equal to angle XAC is equal to ACB. Alternate interior angles. That's easy. So is equal to theta. They both will be theta. So with the help of theta, now we can calculate. If it's sine theta, you'll take it as AB by BC. If it's cos theta, if it's tan theta is what we are going to be mostly using in this chapter. Sorry, it's going to be AB by AC. This is going to be AB by BC. So next, let's move on to the next topic. Let's do a small example. So there's a guy over here. He's seeing a tower. Its height is some 15 meter. We have to find the distance between him and the tower. Let that be x. So distance, let distance between the man and the tower be x. Height is 15 meters, distance is x. So for us, the angle given is 30 degrees, right? Theta is equal to 30 degrees. We need to find x. So with respect to theta, if we take AB as one side and BC as other side, we get opposite by adjacent. What is opposite by adjacent? It's going to be tan theta. So tan 30 degrees is equal to AB by BC is equal to opposite by adjacent, right? What is tan 30? 1 by root 3. AB is h. H is 15 meter and BC is x. Actually, you don't need to take it as a variable. You can directly write it as BC or you can write it as x. So BC is equal, cross multiply them. We get BC is equal to 15 root 3 meter. It's as simple as that. Some sums, all of the sums and applications of trigonometry are very easy. Some of them, they overcomplicate the questions. If we break it down and understand, it's going to be very easy. So thank you guys. Meet you in the next one.